Well, welcome everyone to our first art break of the new year. And while it's a very dreary, drizzly January day outside, we're fortunate to be warm inside and have a chance to really learn more about one of the most beautiful and unique aspects of winter, which is the snowflake. And I think all of us learned somewhere that there are no two snowflakes that are alike. But until you see them highly magnified in photographs, you can't begin to get an idea the intricate beauty and the diversity of a snowflake. And so the goal, this can be a definite challenge for a photographer. It's not as easy as it sounds because snow is essentially ice crystals, which are transparent and very difficult to photograph. And then there's the fact that when they fall, they're very ephemeral and only last a few seconds before they begin to melt. So we're very fortunate to have with us today Mark Cassino, who's a Kalamazoo photographer, and he's been photographing snowflakes over the last 20 years. And during that time, he has developed a number of techniques or methods to create what really come off as these remarkable snowflake portraits, where you really get a sense of the uniqueness of these forms. And this fascination with photographing snowflakes also led to the creation of an award-winning children's book called The Story of Snow, The Science of Winter's Wonder, which came out in 2009. And this book has received numerous awards. It's been used in classrooms all over to teach young children not only about the beauty of snowflakes, but also the science behind them. And I should say that it's rewarding for adults too to take a look at. So, I briefly want to mention that Mark does do other subjects in photography. He's probably best known to many of us as a landscape photographer. His works have been in numerous West Michigan area shows, including the most recent ones. And if you go back to the School Commons area in the showcase, and inside the hallway, you can see some of his landscapes as well as his snowflake pictures. And but that's what we're going to be focusing on today: the unique sort of science and beauty of the snowflake. So please welcome Mark Cassino.
Well, thank you. Thank you very much. I have a presentation here today, and as Greg said, it's about snowflakes. And I should say up front, I use the word snowflake and snow crystal interchangeably. There was a time when I felt that snow crystal was more accurate and more precise, and I tended to use it exclusively, but I found that it really kind of wasn't something that people necessarily connected to. But you'll see in the presentation and in my own language, well, you'll hear in my own language, snow crystals and snowflakes being used interchangeably. And what I'd like to talk about today is the process of kind of figuring out how to take pictures of snowflakes or snow crystals. And that's why this is entitled An Evolutionary Process. I talk a little bit about what my inspiration was and then get into how I figured out how to do it, which wasn't a simple thing. It took several years, because one thing with snow crystal photography is that you're limited to learning and doing it during snowstorms. So you're kind of at the mercy of nature. You can't just sort of say, okay, tomorrow I'll do this when it doesn't snow tomorrow. So you have to work with what is available. And I'd like to start out with a gallery of snowflake photos, starting with my very first one from 1999, and then moving on chronologically to through the years as I gradually improved. You might have noticed this one and the one before it are not the most technically stellar photos. They start to improve, and then gradually over the years get a little bit better and better and better. And over the years, I've continued to work on improving the technique, the lighting, the interpretation really of the snowflake, and working on trying to bring out the internal structures and using different shades of light, really kind of using the light to paint the crystal so that its details and intricacies can be seen. And so this is going chronologically through the years. And as you can see, I kind of changed the aesthetic from starting out with a very dark background and then a very blue background, and then into more reds and purples and pinks, and also trying to get with gradients. And this is my last and most recent snow crystal. I have not done a lot in the last few years, but this is from the winter of 2016. So why photograph snow crystals? I was into macro photography. I got started with photography kind of late in life. So it was in the mid 90s that I actually got started experimenting with it. And of course I was using film since that's all you could do then. And I got very much into high magnification photos, pictures of insects and flowers and seed pods and things like that. And of course, in the winter, it's very hard to find subjects along those lines. So it was a winter day. I was thinking, what can I do in terms of a photographic project? And it was snowing gently, and I was watching these beautiful snowflakes land on the windshield of my car, and you could see this beautiful crystalline structure. And I thought to myself, well, I can do that. I mean, it's similar to what I'm already doing. Also, I was really studying and learning through books how to do close-up photos and macro photography. John Shaw, who's a well-known nature photographer, has a classic book called Close-Ups in Nature. And in the edition I was reading at the time, the book kind of has morphed over the years through the editions, but in the edition I had at the time, he had just a little blurb about taking photos of snowflakes. And then, of course, there's Wilson Bentley, the famous Snowflake Bentley, the person who at the turn of the 20th century, was out taking photos. And he actually left a legacy of a lot of writing, and some of it is actually fairly technical. There's an article that he wrote in Popular Mechanics in 1922, which is accessible on the internet, that really he goes into and talks about his techniques and how he did things. So that all led me to think about, let's get something set up and start looking at taking photos of snowflakes. While I had done macro work before, I had done nothing at this level of magnification. So it was a challenge. So here's my first system that I set up. And I really have only two basic systems. And I'm going to try not to be too technical here, but there'll be a few technical terms that I will need to touch upon. When I was thinking about putting the system together, I thought, okay, what are the challenges here? Well, obviously it's got to be cold. I can't take a snowflake, bring it in the house, and expect to do anything with it. What's the cold temperature going to do with the camera? This turned out to be kind of a red herring, but I was concerned that, the camera will freeze up, or it's not going to work well, or the batteries will die. Big challenge, how do I get the magnification? How do I take this little thing that is, just a millimeter or two in diameter and fill a frame and get a good picture of it? How do I control the exposure? How do I light it? How do I focus? Because one of the things that when you start getting into high magnifications, the focus screen that you look through becomes very dim. So how do I light it so I can see and then focus on the subject? And then how do I control camera shake? If you're photographing something that's only a few millimeters, in size, any tiny movement of the camera is a huge percentage of that. So you quickly lose image quality if there's any kind of motion. So my initial solution was, well, for temperature control, I'll go use my garage. It's unheated, detached, stays cold. The impact on the cold of cold on the camera, I used an all manual camera, all mechanical, I should say actually, Pentax Spotmatic. As it turned out, that really wasn't an issue that I had to be too concerned with. In terms of magnification, I used a combination initially of extension and stacked lenses. And what that basically means is for any camera lens, just through physics, when you push it away from the film plane, the further out it goes, the more it magnifies things. So if you extend, the distance, extension, you get more magnification. Also, if you take a lens of a shorter focal length and invert it and mount it in front of a lens of a longer focal length, it basically functions like a pair of close-up reading glasses. It moves the focal plane closer to the lens and increases the magnification. So when you combine those techniques, you can achieve some pretty high magnifications. The exposure, I used a manual flash, which was a bit of a challenge at times. For focusing, I used macro focusing rails. This is really something where the whole camera mounts onto a set of rails, basically, and you can move the whole camera and lens and everything up and down. And then for camera shake, I decided I'd work in the dark. I'd get everything focused, everything ready, kill all the lights, just let the flash do its thing. So here's my first setup. And basically, I won't go into tremendous detail here, but here's the manual, the all mechanical camera. This is extension. It's a bellows, which can be adjusted, and fixed tubes that stay in place. This is a 200 millimeter lens and a 50 millimeter lens reverse mounted in front of it. And then this is a laptop, an ancient 486 laptop. To handle the exposure, I set up a program that would tell me how much light am I losing due to this extension, because that's one of the challenges with adding an extension is that you lose light, and what is the distance that my flash needs to be from the subject in order for me to get the right exposure. So what I would do is I would focus on the snowflake and then measure my extension, punch that into my spreadsheet, and then I would, here's a screenshot of the spreadsheet, and then it would tell me, I could say, okay, I'm using, and this is not what I was using at that time, but if I'm using this extension, this much extension on a lens like this, then and my aperture is that, here's the effective aperture, and it would tell me how far away I need to put the flash. And so I then take a tape measure and measure it, hold the flash out there, and go boom. And then do it over and over, kind of moving things around, hoping to catch something in the process. So on one of my very first trips out to do that, I really got lucky. And thank God I did. Because I don't know if I would have sustained the effort if it hadn't happened early on. But this one here, I called it powder because I didn't know anything about snow back then. And I thought, oh, this must be what powder snow on a ski resort looks like, which is not the case at all. It's kind of a conglomerate of multiple snowflakes put together. But I liked it. It was a nice crystal. And this one, which was starting to melt because the temperature started to rise, which are called melt away, which is a more conventional form for a snowflake. Those were my first those two shots were my first winter. And like I said, I'm so grateful that I got those because that let me know I can do this. It would be a few years before I was successful again. So that was the winter of 98 and 99. During the winters of 99 to 2000 and 2000 to 2001, I was getting shots like this. Yeah, not so great. And that. This I was so happy with, and it really isn't that good, but it kind of rekindled my hopes. So then I decided I got to change techniques. This is not working. I'm into the winter of 2002, 2001, 2002. So I did some more research and I came up with a new approach. And what I wound up doing is I wound up using a more simple setup. And I changed the technique so that instead of shining the light down on the snowflake, I put the light under it, the flash, and shot up through it. So instead of trying to reflect light off of it and shoot it as an object, I was really shooting it, photographing it as a lens with light going through it. And I got one good photo. And that was this. This is really the first photo I took. This is on film, which has some inherent quality limitations for this kind of work. But this was one of the first really good, in my opinion, snowflake photos, and I was very ecstatic about it at the time. So here is the setup that I switched to. And there's a lot more detail. I took this out of a material I used for a macro photography class, so there's a lot of detail here I'm not going to go into. But I will just kind of walk through the basics. That's the camera. This is a whole lot of extension. And this is just a regular 50 millimeter macro lens. And a macro lens is just a lens that's been optimized for close-up work, but it's mounted backwards onto the extension. Don't ask me to explain it because I don't really understand it, but there's an asymmetry in the design of camera lenses where if you invert some lenses, you get more magnification and less subject to lens changes when you're shooting through using as the front of your lens, the part that normally would be in the camera fixed position from the film. So that is a reverse mounted 50 millimeter. This is just a basic tabletop tripod, some 2x4s to give me a little space, a coffee can with the ends cut off of it, and then a piece of glass. I was using microscope slides before and setting them on a piece of blue construction paper. And that was one of my problems is I was getting shadows going through onto that construction paper. So here is just a piece of glass. I got thick glass so the heat from my fingers wouldn't melt the snowflakes. This is a problem I had with the microscope slides. And then down here is a flash. So it's a fairly simple system, which it really is the basis for, I do a lot of close-up work, and it really is the basis of what I use for almost everything that I do in terms of macro or extreme macro photography. So just a couple examples here. This is the setup here where there's 300 millimeters of extension. So here's the camera, here's the lens. This is 300 millimeters of contained space in between them. The magnification is just over 6x. This is a dime. So if you take out a dime and you look at the word liberty in front of Eisenhower's face, we've got, basically LIB, not all of it there. This is a photo of a ruler, the millimeter scale on a ruler. Okay, so this is basically 1, 2, 3, and a little extra millimeters filling the frame for this. Here, I've cut the extension back by almost half. It's 155 millimeters. The magnification has gone down to 4 times life size. So now you get lib, you start to get the first part of the word. And as you can see, it's 1, 2, 3, 4, 5 plus millimeters. I get the magnification by taking the size of the sensor, this is an APS-C camera, so it's 24 millimeters wide. And if it's 3 millimeters across, and that's 24 millimeters wide, then you can estimate what the magnification is. And here it is in the field. You can see why I went to the other, set it up inside and try to make a nice, neat photo, because working outside is, it's a real place, and it's not always tight. So these are the lights I use so I can see, because you lose a lot of light to this extension. This is not racked out to a whole lot of extension. I was probably working with, bigger snowflakes then. This is actually a much newer camera than I had back when I set this up first in 2001. There's the coffee can. I still use that Hills Brothers can. Same 2x4s, flash. I use a level, because the depth of field is very shallow, so that way I can line it up with the Snowflake. If it's at a little bit of an angle, I can get everything to work. And what I do is I just take a piece of cardboard or black foam core, and when I'm ready to take the photo, I just drop that in front of those lamps, and then I use these days an infrared remote. Before, I used to use a cable remote to trigger the exposure. So, come 2002 and 2003, I really started to get consistent results. Now, I had this preconception that a snowflake should be blue. I don't know why, but it just seemed like blue is cold, so it's cold, it should be blue. So I was putting a sheet of blue plastic over the flash, which in hindsight was probably a mistake, but that characterized my work for several years here, where I would just put this dark blue over it, and I was shooting with film. And sometimes I gave into temptation, would use print film, which is a little more grainy, but more forgiving. Ultimately, I got to where I was working pretty much exclusively with slide film like Fuji Velvia or Kodak E100, which is a finer grained film. But you get this kind of texturizing, and it kind of creates a little different effect. This is one of my probably one of my best film snow crystals, and this was a pure accident. I got the film back. I'm like, so how did I do that? Because it's like, wow, there's a gradient from dark to light. It stands out differently against the background in different parts of the frame. It's incorporating the light into it. I really like that. And so I use that as the basis of inspiration to try to figure out where to go next. And then just a couple other photos from this. And that's a repeat of that one. I'm sorry about that. Or is that a repeat? Yeah, no. This was continuing to look for that. Actually, this was the one from that year that I really thought was, the pinnacle of what I had done so far. So then along comes digital cameras. And, the thing with digital cameras is they produce, for this kind of image, I do a lot of film shooting today. So I'm not biased against film or digital either. They're both great tools, but for certain types of photography, digital does have some advantages. It has much less noise or grain. It creates a much crisper and clearer image, and it just creates just a better quality image where you can see the detail and the edges compared to even the best transparency film. The word there, better accutance. Accutance is the ability of the photo to depict changes in contrast. And with film, you might have black and white, but there'll be a little band in there where you go through the shades of gray. With digital, you're much more able to get black, white, crisply together, which makes the edges look sharper. So I started getting photos like this, which I really like. I was kind of blown away. It just using the same technique, still using my piece of blue plastic. I just started to get some better images. And I'm going to comment on some of these crystals as we talk about it and start talking a little about some of the things with snowflakes. One of the things that I am attracted to is I like the irregular symmetry. I like things that are symmetrical but not perfect. I kind of feel like perfect is a human construct, and this is more the way nature does things. And one of the things that throughout this has just blown me away is when you see something like this where this arm is longer than the others. That's because during the life of that snowflake, life in quotes, when it's up in the cloud floating around, it drifted towards some place where there was more humidity. And this arm was exposed to slightly more humidity than these other arms, and therefore it started to grow. And it blows my mind to think that there could be, at the scale of a snowflake, we're talking about something that's a few millimeters in size at most, that there could be enough difference in that short distance. I mean, you're talking here just a few millimeters. So this can experience a somewhat different environment than that. And to me, the fact that things work like that at that scale is just fascinating and to be frank, kind of incomprehensible. This is a very classic symmetrical snowflake. This one I like because it was really starting to capture the translucent nature that I started working with a little bit more in the future. This one is more of a profile. This snowflake is this is a 12-arm snowflake. All snow crystals have arms and multiples of 6. That stems from how H2O, water, you have a hydrogen, 2 hydrogen molecule atoms attached to a oxygen atom. Those 2 hydrogen atoms are at 60 degrees separation from each other. When they link up to form crystals, they form things that tend to pattern out to 6 because of the angle of the atoms and how they combine. The explanation I hear for 12-armed crystals is that it was really 2 snow crystals that stuck together very early on and started to grow out from a common starting point. Because snow crystals will grow from pieces of dust or pollen or even bacteria in the air. Water vapor can't crystallize unless it is on something. So when you have a very saturated atmospheric area full of water vapor and a particle of cold dust reaches up to it, the water condenses on it and starts to crystallize, and that's how it grows. So anyhow, this is a 12-armed crystal. I've only seen like 3 or 4 of those in all the years I was shooting snowflakes. And this one I just like because it's so irregular, and this is my absolute favorite for that year. I like to think of it as a little robot or something. It just has such an interesting and unusual shape, and you can see multiple crystals embedded in it. This is a simple plate crystal, and then it's got its core. And there's always interesting things happening in the center of a snowflake. Okay, so in that year, one of the interesting things was a reporter for Newhouse News Service did an article, and she wanted to talk to all the snowflake photographers in America. And so she talked to basically 4 of us. And lucky me, I happened to be in a town that had a Newhouse paper, so they sent the photographer over, and I got my picture with the photo, even though about the only quote from me in there was where I compared myself to Homer Simpson in doing my first setup. But that was kind of interesting because there are lots of people doing it today. It's a lot easier, digital cameras. Back then, there was just myself, Patricia Rasmussen, who worked with Ken Librick. Ken Librick is like the king of snowflakes. He's the physicist at Caltech, who just spends his life studying and photographing snowflakes and has all the beautiful books out there. And then Ted Kinsman, who's a science and education photographer, I think, in Rochester, New York. So over the next few years, I continued to make some gradual improvements. And I got rid of that heavy blue filter, and I started using multicolored plastic illuminator filters, which are basically the little thing that goes on your holiday lights to make the LED look blue or red or whatever. And to show you here on our picture of the setup, if you look in the coffee can, you see this. And just simply putting that on the flash, no sheet of plastic in between it, because I used to actually put like a square of plastic, and I would try angling it and having 2 sheets where they're separate in one area, and then they kind of combine like a wedge. really couldn't get the gradients. This helps me get the gradients. I mean, this really works. It just puts some blue light into part of the light that floods that coffee can. You know, it's all bright silver inside, and you just start to get this nice gradient from light to dark. So here's a piece from there. Now, this one was interesting because it is actually was melting. And because it melted, it fused to the glass and it created a little more luminous effect than others. But here are several others. This is a classic snow crystal. This one, very nice gradient, nice and sharp. I think the Sierra Club used this as a Christmas card one year. This is a rather odd looking plate. And it has either rime or air bubbles in it. It's hard to tell from the photo what it is. But these little dots you see on it, if the snow crystal in the atmosphere encounters a mist, it can get small droplets of water land on it, and they will freeze, and they will become little drops of rime, R-I-M-E. And again, that discussion about scale, you know, there's a little break in here. And the idea that some force could come along and break something that is tiny, you know, how does that work? It just something that amazes me. This is probably something like a sectored plate. A plate snow crystal is just one that is a hexagon. And then as it starts to grow arms, it becomes either a sectored crystal or, you know, one with the dendrites, you know, or dendrite type crystal. Another interesting one, again with the rime. This one was interesting. It was withering on the ends, and it looks black here, but that's a limitation of the process I'm using where I shoot through it and use it as a lens. Because if you were to look at this under reflective light, these would be bright white. They've just become frosty and transparent, or not transparent, opaque. Here's one that seems to have almost broken in half and then put itself back together again. It's, like I said, just fascinating. It's a pair of crystals. And as you can see, I'm experimenting with different lights, different colors, still in the blue family though. A very simple dendrite, a little more complex dendrite. I sell these as cards around Christmas time, and this is probably the single most popular one. It's got a little bit of doubling down here, and again, that asymmetry, which I find to be very interesting and compelling. And then this was an experiment where I didn't use any kind of coloring at all. I just had the light bounce around and come out in a color neutral tone, and, you know, maybe tinted it a little bit by adjusting some sliders in Photoshop. And the same thing here. I just like this one. It's just got kind of an aggressiveness to it. One thing with snowflakes is they sublime very quickly. If you remember from chemistry classes, sublimation is when an object goes from being a solid to a gas without becoming a water first. So it just basically evaporates directly from the solid state. And when you see one like this, where you can see it's withered at the ends, it's subject to sublimation. And when I capture the snowflakes and bring them in, depending on the weather conditions and the humidity and things like that, I can see them over the course of time subliming. It's not like you can actually see it happening, but I'll look away, focus, and look back, and it's different. Or I'll look at the shots I take, because it usually there's some fiddling and adjusting of the lights. One nice thing about a digital camera is I can see what I got. So I can take a shot and say, oh, I got to move the light a little over this way or that way. And then I can look at those pictures and just see it shrinking in the 10, 15, 20 seconds it takes between shots. And that's one of the biggest challenges with this, because in some conditions, you can really just have a minute or so before it becomes pretty degraded and is just really a shadow of itself. Wilson Bentley talked about that in his article, and he used to make like nests of snow. He'd get a nice, good sized snow crystal, and he'd set it on the where he was going to take its photo, and then he would just grab snow and kind of create like a nest around it, trying to create an area, a micro area of high humidity that would slow down the sublimation. So this is another one, kind of the same thing with some of the sublimation going on. Then we got into 2009 and 10, and this is where I began experimenting with different colored backgrounds. So this one is kind of plain. It's just really probably with nothing going on around it. Then we're back into the blue. This is a sectored plate. This really, I think, was two crystals, or it grew in two different ways, because there's one layer here and there's a layer behind it that it's on top of. And then here's where I got going with like the red snowflakes, or red filters. So you get a red light kind of moving over to a clear light, and then you get the snowflake kind of capturing that light and refracting it within itself, and creating a red, green, blue effect within itself. So I'm really using the snowflake as a lens. This one I just kind of like because it's kind of weird, but this was a very three-dimensional one, and I just could just imagine it falling through the sky, so I just cropped it to give it a little more room. Again, this is rime or air bubbles inside the snow crystal. Rarely I will see, but not uncommonly, I guess it's not all that rare, I will occasionally see a plume coming out of the center of the snowflake. I've never read anything that really explains how that works, because they're usually treated as basically flat crystal objects, but this is a plume that's rising from the center and up towards the camera, going out of focus. This is another example of using the lens itself, or the snowflake, as a lens. And there's not that much gradient. There's some there, but I just loved how it picked up the reds in some edges and then actually moved over into some of the greens and things and others. And some of that might be chromatic aberration from the lens itself. I don't know if it's the lens, the snowflake, if the light from the snowflake and interacting with the lens, exactly how that's working. Another experiment with a little different kind of color filter. And then I tried some subtle things where, the red filter on the flash was really kind of put off onto, far to one side, and the flash position, so it wasn't really shooting right through the red. And here you're just getting the red light refracting out through the crystal, really not much of it showing at all in the background. And so we just have a few more examples along that line. And this is where I really felt like I kind of come onto my own in terms of, thinking back to that first winter, and then that one shot I was so proud of back at the beginning. And then looking at this quality, the work I was getting here, just feeling like this was working out well. And I just love the textures and the detail. It is a very time-consuming process. I would spend hours and hours outside. That's part of the reason I don't do it much at all anymore, because I'm not as invincible to the cold anymore. And but I could spend literally an afternoon outside, and you would get little windows where there'd just be nice quality snowflakes falling, 10, 15, 20 minutes. And then you might have an hour where it's just broken up and messy, and it just doesn't come together. This is another one with the rime and the air bubbles. And a real case of that, and even worse, and more. Another stellar dendrite. And going on into subsequent years, continued to work with the filters and trying to really capture what's going on in the snow crystal itself with a different colored light. This one was from, I think there was a big snowstorm we had in Groundhog's Day sometime back in that time frame. And what I found interesting here is it's actually kind of scalloped and worn. You can see areas where it's not crystal growth, but where the wind has abraded it and worn away, and it has like the feel of something that's been worn. And you don't see rounded edges in crystals. They're angular. Um, and that's where I think of, okay, the mass of a snowflake is very small, and to get resistance, you have to have inertia. To have inertia, you have to have mass. And so when wind hits it, I would think it would just go with the flow and move, and not have enough resistance for the wind to flow over it and wear it away. But I'm not a scientist, so I just think about these things. Another one from that same snowstorm, and yet another. And here you can really see how abraded it is, and it's got this almost like a sand dune type texture, or a piece of stone that's been worn away. But stone has thousands of years where it happens, and snowflakes have probably a few minutes. 2011 and 12, no snow. Didn't get any photos. And when I say no snow, it probably snowed, but like the snow this morning, there would be nothing useful that you could take a photo of. It's wet. Snow like the blizzard before Christmas, the wind destroys the snowflakes. You get dust. You get arms and legs of snowflakes. You don't get snowflakes. So that year, no luck. And then just for the few years beyond that, where I continued to do it, what I really consider, the current best work that I have, and this is just a collection of a few snowflakes here, using different color schemes. I kind of went back to doing some of the blue because a lot of people, the feedback I got was they didn't like the red. They said, they were kind of embracing my logic earlier and saying, well, they're supposed to be blue, aren't they? And some very large stellar dendrites. These snowflakes can be down to a couple millimeters in size. In a few cases, I've seen them up to a 1/4 inch in size, though, and they're really kind of rare at that large size. This is where I thought I'd try some things with Photoshop and try to enhance some of the colors. So I'd have some red in there, but try to kind of skew the neutral colors to blue. I don't think it was all that successful. Same thing here. But my philosophy is, well, let's keep doing something new and different. Another one I really liked with the red captured in there. And, what I felt in these last years, this was a really tiny one that was probably quite old as snowflakes go, is I really just felt like experimenting and working with trying to play with the colors and see what we have in terms of bringing out details. This one you can see is, again, asymmetrical, very asymmetrical. But I kind of feel like it gives it a sense of dynamics. I feel like this one's like running across the room here. This is one of my all-time favorites. It has this kind of strange organic thing in the middle. I think of it as a cat, but it has this kind of unusual shape. And then this is another example with the red filters. And then this is my very last one that I took in 2016. I haven't really been venturing out. You can see the water on the plate. Sometimes I'd go in and kind of Photoshop that out and kind of clean it up around it. But I did like the blend of the blue, the red, and just the clarity of it. The center, every snowflake starts with a plate formation, a hexagon in the center. This one started with an irregular hexagon, but grew to be a fairly regular shaped snow crystal. So that was enjoyable. So just a few interesting examples. Doesn't really convey here, but these were, I mentioned snowflakes that were a 1/4 inch in size. These two are examples of those. To catch the snowflakes, I take a square glass and I go outside the garage and I stand there and I let the snow fall on it. I wear contact lenses when I'm photographing because I can align my eye onto the finder better. And so I have on pretty strong reading glasses so I can see the snowflakes clearly. They're small. And Lots of times it's kind of a race of, there's a really nice one that just hit, and I got to kind of cover it up and get inside before it gets clobbered by others, depending on how fast it's snowing. This night, if you looked outside, you wouldn't even think it was snowing. I looked out and I could see in the porch light every now and then these snowflakes falling. And I went out and they were spinning and falling flat. And they were big enough that you could see the individual snowflake. So instead of just going out and kind of holding the glass out like a net and just seeing what landed on it and pulling it back, I could actually walk up to it and catch it, take a look at it, and go take a photo of it. There are only a very few. I have found in my own experience, it's usually at the beginning or the end of a storm that you get high quality snowflakes. When the storm is really raging, the quality typically goes down. But somewhere in there, snow always kind of comes and goes, and it gets real heavy, and then it kind of eases up. In those transitions, you can find some more things. Just an example for lighting, just to show how moving the flash a few inches makes a world of difference. And so this is where I cannot look at a snowflake and say, okay, I need to put the flash here. I wind up doing it, taking a photo, and that didn't work, go the other way. And sometimes you get two that, in their own different way, work. Here's another example. This is another one of those 12-arm snow crystals. This one's a little more gnarly than the other one. But again, where it's here like kind of on the positive, brighter than the background, here it's darker than the background. And again, just moving the flash an inch or two can make that difference. I've got to decide pretty quick because it's going to be sublimating, or I've been told the word is actually subliming as I'm fooling around with it. This is just one, again, kind of withered around the edges. In the book, Story of Snow here, which is the book that I authored, we talk about the snowflake being a letter from the sky. And I said I authored, but we had a science consultant, John Nelson, who's a physicist, who helped a lot in terms of explaining things. So we were able to get the science right in the process. And he talked about in Japan, where he was based at the time, there's a saying that the snowflake is a letter from the sky. And what he meant was, as it starts to fall, it changes. It will crystallize in different ways depending on the atmospheric conditions as it drops down, the humidity. And so this thing obviously got into a situation where it got wet or it got melted, things got warmer, and the periphery just stopped forming the way they would. But if you read some of Wilson Bentley's things, he actually looks at snow crystals and will say, well, this started out in this setting, and then it went to this, and then it went to that. I don't know how he knows, but he knows a lot about snowflakes. I called this the faces of water. This was a mistake. It was getting warm, and I put a snowflake on the glass, brought it in to take its photo, and it melted. But I caught it just where there's this skeleton of the snowflake in the drop of water. And I thought, wow, that's cool. So I did, from time to time, intentionally try to do that and use different lighting effects and things like that. And I don't know exactly what's going on with these, if that's just a very thin layer of glass or glass ice, or is that, how many molecules thick is that? I don't know. It was just a very fascinating experiment, especially here where it's the water and the ice creating a refracting effect with the light. So you get some really interesting types of things. Another one here, this is all that's left of whatever that snowflake was. And well, actually the puddle is all that's left. This structure is all that's left of its form. This is kind of what you at best could get on a day like today, where it's wet. The snow, you do get the advantage of the snow kind of fusing to the glass, but I called it snow mixed with rain because it was basically a rainy day. And I got the idea at one point, well, why don't I just chill the glass down and then it won't melt? But that's true, but the glass will get condensation on it. So that's the result you get from that. And then this is why I didn't use the word snowflake for a long time. I viewed snow crystal as a single ice crystal, and a snowflake, which is when we have those snowstorms where you see the big flakes that look like cereal, white cereal falling down through the sky. Those are really globs of snow crystals. So I went out and took some photos of snowflakes because you can see there's a whole lot going on in there. There's a lot of fascinating and really neat crystals. You really can't see them. They have stuck together, fallen together, and most of the time it doesn't fall like this. But when you see those days where you can see those big flakes kind of usually sort of just seesawing through the sky, that's what they are up close. And this is what falls the most often. And you go outside, and especially in a windblown storm, the snowflakes have formed, and they've been chewed up and demolished by the wind. So you get the little broken bits and pieces of them that then congeal back together. And I mean, you can have snow like this fall for days straight, and it never gets any better for some reason. And then lastly, this is one that it just has always fascinated me. This was in the same series from the Groundhog Day thing, and it's got the scalloping and the wind wear and things. But what really fascinates me about this, and I don't think I'll ever be able to explore it in an orderly way, is if you look at this, you can see these striations, these layers, almost like a grain inside of it. And those are, I guess, layers in the snowflake where, as it formed, it kind of formed some layering effect, and or maybe a hint at what the internal structure of the ice itself is. Or maybe it got stressed and somehow got micro cracks in it. I don't know, but it just struck me as a really fascinating thing. And again, the fact that this can happen at that scale, where you've got the scalloping and just the wear, the organic wear, and as it shows up in here, on something that size just continues to blow me away. So, adventures in publishing. I self-published a little book called Imperfect Symmetry in 2007. And then I wound up working with Chronicle Books, a publisher out of San Francisco, and we published The Story of Snow, The Science of Winter's Wonder. And again, that was in collaboration with John Nelson, who is a physicist who I knew from the internet as someone who would call me up and say, can I use that snowflake photo for a paper I'm writing or for a poster I'm putting together for schools or whatever? So this is the Story of Snow cover. I have, I think a couple copies are over there. A copy here is a prop. The book was very well received. I was a little surprised. Oh, this is a page from the inside. Working on a book like this as an artist, it's a different experience for me because I tend to do everything myself. I create the piece, I figure out how I'm going to present the piece, and I get everything done. This is more like being part of a movie. You've got an art department. They hire an artist to do the illustration. You are working with editors who are saying, okay, well, we're going to have this much going on. So it was a very interesting experience to put it together, and I really like the quality of what came out of it. The book is only about 1,000 words long, so it's War and Peace. It is not. So some awards and recognition. Very quickly after it was published, it was named an Outstanding Science Trade Book by the National Science Teachers Association. It won a blue ribbon from the Bulletin of the Center for Children's Books. It was on the Chicago Public Library's Best of the Best list for 2009. It won the American Meteorological Society Louis J. Baton Author Award. the Junior Library Guild selection. It was a finalist in the American Association for the Advancement of Science / Subaru prize. It was named by New York Public Library, 100 Best Titles for Reading and Sharing. And this isn't really an award, but it was, I think, really one of the most phenomenal aspects, or one of the best things that happened for the book is McGraw-Hill sublicensed it and put it into their reading series. So it is used or has been used. I don't know if it is still currently used, but for many years it was used in McGraw-Hill's anthologies of reading books that they had put out, and really got in front of the eyes of thousands of kids that it would not have just as a commercial book. Kind of ironic, though, it was in their middle school curriculum, and we intended this to be a book for K through 3. So we were maybe a little, didn't understand our audience as well as we hoped to. It has also been translated into international editions, starting with the Japanese, Chinese, Korean, and Russian edition. And this is the cover of the Japanese edition. And it's kind of interesting because that edition was published at a size about 80% of this. If you put this next to Snowflake Bentley, the much more popular book about Wilson Bentley, they're exactly the same size. I think that was something the marketing people did on purpose. So just a picture of a snow crystal on a mitten. That was a request from the editor. Just a few final thoughts, and for more information, thestoryofsnow.com is a website that I originally set up as a blog to promote the book. John Nelson, who was a major contributor to the science in the book, took it as a forum to publish papers. So if you want to read about ice and crystallization, there are dozens of academic papers by John Nelson out there on storyofsnow.com. And if you drill down into it, you'll see where it initially began as kind of a promo to help promote the book and talk about events about it and things like that. And then just my personal website, Snowflake Photography, is one of many projects that I work on, and I've got some of my own my photography there. What I have found about this is the way I've come to view photography at this point is I'm always working on different projects, but they always build and support each other. So what I learned in taking pictures of snowflakes became really the basis for several other projects on macro photography, ranging from focus stacked photos of insects to detailed photos of botanical subjects, to crystals in rocks and minerals. So everything that I wind up doing seems to wind up then becoming a tool that I can use for something else. And I take it to something else and learn something there, and I can go back to that and use it again. So it's just kind of an ongoing process of learning and discovery. So that is everything that I have at this point. And I think, let's check how we're doing for time. Well, we're at about an hour right now. So any questions? Yes.
So when you're gathering your snowflakes, do you hit several on your piece of glass and pick out which ones you like? And then the other question is, have you ever tried to use a gold or yellow light to influence your snowflakes?
Okay, yeah. In terms of the second question, yes, I have used a yellow light, and it's the only one I don't like. So I didn't put any here. I've experimented with yellow and with green, and there's just something about them. They just don't work for me visually. In terms of gathering the snowflakes, it depends on the situation, but I will usually, if I see something that looks promising, scoot right into the garage because the clock is ticking on it for sublimation. So if it doesn't, if I don't get in there and get started, because it takes a few minutes, I got to get it on the coffee can. I have to adjust the magnification by adjusting the bellows, then rack the whole thing down using the focusing rails, get it in focus, do my first shot, and then start adjusting the lights. So it's got to go really fast because that thing will immediately start to wither. What I'll do is I'll take either a very sharp pencil or a larger pin, like maybe a needle, I guess it would be like a darning needle, something that is small enough that I can move anything around that is blocking it. So a lot of times I'll get a nice crystal and something right next to it, and I want to get that out of the frame. So I'll move that around too as another step. One question. Yes, sir.
You use the adjective stellar, like a star, for a snowflake. How about the reverse? Has anyone tried to photograph a star and found it like a snowflake?
Yeah. I don't do photography, so I don't know. It's not an area of expertise for me. The term stellar dendrite is used by snowflake scientists. And dendrite refers to like a fern leaf, is a plant type structure. There are these classification systems. There's a long article on Story of Snow by John Nelson about the classification structures used for snow, they use a variety of terms. My guess is that a star is going to be a circle because it's a ball of hydrogen, but I don't know. I've never even photographed an eclipse, so I don't know. Yes, sir.
Many of your photographs certainly suggest a three-dimensionality already, almost making me want to turn them on the side to see another dimension. So I'm just wondering, as before a snowflake actually impacts on the glass, and in some ways flattens itself so that it can be photographed. Has anybody tried to make high-speed video as it's turning and falling so that we could see all dimensions of it? We could walk around it like the sculpture it is.
Not that I'm aware of. There are several photographers, though, who don't take the approach I take, which is to basically treat it as a flat object. And I think most of them are fairly flat, but who will catch it like in the fibers of a sweater. I don't know. I don't remember his name right now.
Photograph is very close.
Yeah. The mitten photograph is, but there's a photographer in Russia who does them on like a black piece of wool. And his will have that three-dimensionality. And then there's another photographer in Canada, I believe, who does a very 3D effect where he focus stacks, which is where you take multiple photos of a subject. When you photograph at high magnification, just to explain that term, the depth of field, the area that is sharp, is very, very small. And the way you increase that is usually to stop down and constrict the aperture. But at high magnification, that leads to real problems with diffraction. So you don't get a sharp image. So what you can do is take multiple photos, slowly moving the camera, and then use computer software to combine those things together and create a 3D model. And there is a photographer, I think his name is Don Comachara, who does that with great aplomb, stacking the photos. He's got to be really fast, and I think he actually does it handheld, which I can't see how he is able to do it. Because the problem I would see with focus stacking, and I do a lot of focus stacking for other subjects, is that you can't really, it takes time. You've got to do multiple shots, 20, 30, 40, even more shots. And in that time, the snowflake is changing. So when you go to stitch them all together, it's going to be a little different. But no, I think that is kind of an interesting concept to see it in a three-dimensional thing where it's moving. Yes.
Is there an ideal temperature that you've found that you can capture more snowflakes?
Okay.
Or better quality?
The question is there an ideal temperature for it? And I can't say that I would rule any temperature below 30 out, but I've generally had my best success in the upper 20s Fahrenheit.
Humidity, that's factored.
Yeah, humidity is factored in. It seems that when it's very, very, very cold, the air is dry, and by the time the snow crystal lands, it's already begun sublimating and can be withered. But I have gotten some good ones in very, very cold weather too. So I can't say I wouldn't not go out just because it's 15. I might not go out if it's 5 below 0, but that's not because of the snow. Yes, sir.
It looked like you had quite a few from 2013, and as I recall, that was the vortex year. It was cold and dry for months.
Yeah, that's true. That was the question was several of these are from 2013 when it was a very cold and dry year. And yes, I don't really have records, so I can't really say. But like I said, I will go out. My impression, my recollection is that I usually did pretty well at the beginning and ends of storms. And that's also probably the period where you're either getting warmer or getting colder as the front comes through. And there are cold days, though, that have worked well. The days where I was getting the really big snow crystals, it was almost too warm to do it. It was probably around 30-ish. And one thing that I learned from doing this is just how different microclimates are. Just my garage, which is outside, it's 100 years old at this point, no insulation. I'd open the door when it got cold, and the door could be open for a couple days. But I could go in there, and it would still be 4 or 5 or 6 degrees warmer than the outside. And just because there's all this mass, all this stuff in there. I used to store firewood under the table where I did the snowflakes, so there's all that wood. But it just took time to cool off. I'd actually put a fan in there to try to blow some of the cold air in. Okay. Any other questions? Well, thank you all for coming by today.